Welcome. This is going to be our lecture video for May 4th. We're beginning our last unit, a review of everything we've covered so far. We go ahead and get started with this due now. So looking at this pattern, how many boxes would be in the 30th shape? Well, it would take a really long time to draw out the next 26 shapes, and towards the end they'd be getting really big and be very easy to make a mistake. So we've got to use math here to figure out how many boxes would be in the 30th shape. And a very useful tool is a table to help us start thinking about this. So this will be the shape number in our first column. So the shape number, and this will be the number of boxes. All right, and let's copy down what we have. In the first shape, let's even get a little first underneath there, we see 1 box. In the second, I count 3. In the third, I count 5. And in the fourth, I count 1, 2, 3, 4, 5, 6, 7. All right, do we see a pattern over here? Can we use this pattern to get all the way out to the 30th? Well, it looks like we are adding 2 each time. All right, so every time this moves up by 1, this goes up by 2, so that means that our slope m equals 2. Now all we need is our b value. And it's really easy to make a mistake here and say that the b value is 1. But the b value is the number across from 0. So if I wedge in a very small 0 up here, what number would keep the pattern consistent? Well, it's a -1. Because then if I add 2 to -1, then I get to +1, and then I get to 3, and then 5. So my b value is actually -1. This is the tricky part. Don't go with 1, you have to count backward to the 0th shape, and it's got -1 box. I don't even know what that would look like, but it makes the math work out. So now I can say y equals mx plus b, y equals mx plus b, where 30 goes in for x, so y equals 2 comes in for m, times 30 for x, minus 1 for b. Here, let me fix this, it looks bad. Equals mx plus b. All right, so y equals 60 minus 1, y equals 59. There would be 59 boxes in the 30th shape. All right, and 30 is not that big of a number that if this was on a test and you wanted to double check your work, you could count all the way up to 30 by just adding 2's to make sure that it's 59. But once you're confident with your math, you can just go with that. Goal today is to review how to continue linear patterns and write expressions to represent them. While we're doing this, patterns happen all the time in the world, and it's useful to write equations for them. Those equations help us then make predictions if we see a pattern. All right, here's some patterns to continue. We have to look to see if it's an adding pattern or a subtracting pattern or something different. These all look like adding patterns. Let's double check. So +2, +2, yep, we're adding 2 each time, so this would be another +2, 21. All right, these numbers are a little bit bigger, so say I couldn't figure out what I need to add to 1 to get to 7. Off to the side, you do 7 minus 1, and now I see we need to add 6. So that makes this a 37. Here, what are we adding? Well, 11 minus 8 is 3, so 8 plus 3 is 11. Double check that the +3 continues to work. 26. Try this last one on your own, and we get 51. All right, some more patterns. Identify the pattern and fill in the missing numbers. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Copy down as many more as you want. I'm going to pause the video and fill these in, and then you can double check, so pause it now. All right, so here it is all filled in. Anna did the second part of this, which was identify the pattern. These were all either adding or subtracting patterns. So I just said for this one we add 2, this one we add 2, this one we subtract 4, this one we add 5, this one we subtract 2. One thing to notice is with the add 2 and subtract 2 patterns, if they start even, they stay even, and if they start odd, they stay odd. Just a useful thing to notice with those add to patterns, which are pretty common. Okay, another thing I could ask you is whether a pattern is linear or nonlinear. Let's create a quick definition for linear. This is a pattern that adds or subtracts a fixed amount. And nonlinear is everything else, including multiplying patterns. All right, so it's easy to mistake a multiplying pattern for linear because you see the pattern, but it's not an adding pattern, so it doesn't count. All right, is this first one linear, nonlinear? Well, I'm adding 2 each time. Double check that it keeps working as you go through the pattern. This one is linear. I'm adding a fixed amount. What about this next one? Well, if I have to go with adding, then I would add 1 and then add 2, and already we can see that this is nonlinear. This would be an easy one to make a mistake on, though, because it is a multiply by 2 pattern. So if I write it as times 2 times 2 times 2, it looks like it's being consistent, but it's in a nonlinear way. All right, next one. How do I get from 9 to 5? Well, if you do 5 minus 9, you get a negative 4, so I must be subtracting 4. Let's see if minus 4 keeps working. It does, even into the negatives. So this one is still linear. Linear patterns can go negative. In our last one, we add 0, then we add 1. That's nonlinear. This is not a multiplying pattern either. It's a very unique pattern called the Fibonacci sequence. So the Fibonacci sequence is this pattern that goes 1, 1, 2, 3, 5, 8. And it's really common in nature. And how we get it is you add the 2 previous terms to get the next term. So this next term would be a 13. And if I add the 8 and the 13, I can find the next term. Together they make a 21 and then a 34 and so on. Okay. What is this pattern? 1, 3, 12, 13. So look for the pattern, see if you can write it down. All right, here's what's happening. We're going times 3, then plus 1, and then times 3, and then plus 1, and then times 3. So this is an alternating pattern. Of times 3 and plus 1. And you can have even more complicated alternating patterns. They can alternate between multiple things. It could be like an alternating pattern of adding 3, multiplying by 4, dividing by 6, and then subtracting 4, and then that repeats. And those can be really hard to pick out if it's not just 2 things alternating. Okay, here is another sequence. When we start calling things sequences, we can start labeling them in a specific way. You can label the whole sequence with a letter. So this could be the sequence A, and then you give a subscript n. So this is a little n to represent where in the sequence we are. So this first term here would be A sub 1. This next one would be A little 2 or sub 2. This last one here would be A sub 5. So watch out for that on the homework. That's how some of the terms are labeled. What's the next 2 terms in the sequence? Well, it looks like it's an adding by 5 sequence. So we get a 28 and then a 33. Create an XY table for this sequence. So the X is going to be the term number, 1, 2, 3, 4. And then Y will be the actual value of that term, 3, 8, 13, 18. So it's just this pattern, but vertical. And we've got all of our integers written down over here. What's the starting value? So it's really easy to say the starting value is 3. And you can think about 3 as being the starting value, but then it makes the equation much harder to write. So it's better to count backwards 1 and we would get negative 2. So if we add by 5 to move forward, we can subtract by 5 to move backwards, go back to the 0th term, and it's a negative 2. Write an equation for the sequence. Y equals our common difference of 5x minus 2 will be the 20th term in the sequence. We put in 20 for x. Y equals 5 times 20 minus 2. That's going to be a 98. Plug that into your calculator. Okay, that's that for this video. Good luck on the homework, and have a good rest of your day.